So for trig transformations, we'll start off with our basics and just some of the fundamental facts about our standard trig functions of sine, cosine, and tangent. We've talked about the period for these when we've had to do trig equations. We end up with this 2 pi k factor. And again, what this means is that sine and cosine are going to repeat. They're going to repeat the same values every 2 pi. Meaning that if I pick some value, x, and then I add some integer multiple of 2 pi, well, what are we doing? We're just wrapping around the circle. So whatever x is, whatever angle x is, if I add 2 pi to it, I'm wrapping around the circle and we are back in that same position. So while the number is the same that we use to describe that angle, the ratios of the side lengths are always going to be exactly the same. And so sine and cosine, we say, are periodic and have a period of 2 pi. Tangent, on the other hand, because it is the same in the first and third quadrants, as well as the second and fourth, it's going to have half the period. The period is going to be pi. Tangent is going to be a little bit different, but the graphing process, it's going to be essentially the same. What we like to do with this graphing process is actually just cut the period in the fourths, and we'll use those as our tick marks for our graphs, and then graph from there. So let's take a look at the standard graphs first and how we go about doing these. Once you understand the standard graphs, how to start, and then where to go and how to just draw the, fill in the dots essentially once we plot the dots. Doing some of these shifts and stretches and scales, it's not too bad. So sine, the way we're going to graph these is almost always start off, draw your graph, and then put 4 tick marks on either side of the axes. So for sine and cosine, I'm going to make the axes, make the tick marks spread out a little bit on the horizontal axis, just to give us some space to draw it. And then the vertical axis, the range of sine and cosine goes from -1 to 1. So we actually only need 1 tick mark above and below for our y-axis. And those ones are just going to be our 1 and -1. And in typical graphs, if you had to graph them by hand, we like to see 2 periods. So if every 4 tick marks is a period, usually we have 1 period on the right, 1 period on the left. So how we're going to graph these, I'm actually not even going to label the horizontal axis yet. Let's just go ahead and start off by graphing sine. The thing to remember with sine is that sine starts at the origin. So it starts at the origin, and moreover, it goes up and to the right. So your next point, you're essentially just going to oscillate then. If we're at the origin, this is going to be the midline. So sine starts at the midline, goes up to a peak, go over 1 tick mark, back to the midline, over 1 tick mark, now down to a valley, over 1 tick mark, back to the midline. And once you have those points, you just connect them. Likewise, we do the same thing on the left, except now we're going downward. So from the midline, we go down to a valley, up back to the midline, up to a peak, back to the midline. That one should be over to the left a little bit. And then connect the dots. And that's sine. Cosine, we're going to do similarly. So we've got our 4 tick marks either side of the axis. We're going to draw plus and minus 1 on the vertical axis. And then the thing to remember about cosine is that cosine starts at a peak. And when I say start, I mean relative to our axis. So we're starting at x equals 0 is our typical starting point. It'll shift if we have horizontal shifts going on, and we'll deal with those when they come up. So cosine starts at a peak, which means when we move to the right, we'll hit the midline, down to the valley, up to the midline, and then back to a peak. Connect the dots. If you want, you put your little arrows in to indicate that it keeps going. And now moving to the left, we're starting at a peak. So the only place to go is down to the midline, down to the valley, back up to the midline, and then back to a peak. So you got your dots, just connect them. So that's going to be the process essentially for sine and cosine. And tangent, it'll be similar, but the way we draw tangents is a little different. And it's almost better to label your axes at the end. Vertical axis, it's usually pretty clear from the amplitude, but horizontal axis, you can essentially just label once you've finished graphing it. The full period is 2 pi for our standard graphs, which means each tick mark is a fourth of that. So 2 pi over 4 is just pi over 2. Usually labeling one tick mark is good enough to indicate how far or what the range is for each tick mark. If you want to fill in the rest, feel free. So pi and 3 pi over 2 would be those other ones, at least on the positive side of the x-axis. So tangent, we're going to do similarly. We're going to have 4 tick marks. I'm going to keep them a little closer because tangent, there's the 4 tick marks I draw. It's really like you can get away with drawing 2. You don't need to draw 4. But for the sake of plotting some accurate points, it's always nice to draw 4. And so the thing with tangent, what's going to happen is that if our period is pi, halfway of the period, so pi over 2, we are going to have asymptotes. So odd multiples of pi over 2, tangent always has asymptotes. Another way you can count these is from the starting point. So tangent, just like sine, starts at the origin. So I know I'm going to have that starting point. And then every 2 tick marks, it's either going to be an asymptote or another starting point. So I go over 2, I've got a tick mark, or I've got an asymptote. I go over 2, we'll have another point here. So over 2, asymptote, over 2, point. And then if you wanted to keep going, the next asymptote will be at 3 pi over 2. Negative 3 pi over 2. 5 pi over 2. So odd multiples of pi over 2. And then now what tangent is going to look like, it's essentially in between each asymptote, it's going to look like a cubic function, except it's just going to trace the asymptotes. And that would be a pretty good graph. If you just draw a cubic, that would be pretty accurate. One thing we may want to do is add in a couple extra points, since a lot of a lot of the graphing problems we've done, at least the ones you have to do by hand, we usually grade you on a couple of points. So for like parabolas, right, you usually want to plot the vertex and then maybe like a couple other points to indicate how broad it's opening. So what are the other points we want to plot? Are going to correspond with the extra tick marks we drew. And it's just, well, half of pi over 2 is going to be pi over 4. And what is tangent of pi over 4? 1. So double check your reference triangles for that. And so easy way to graph it, some extra points from a starting point. You go right 1 and up 1. And then you can go left 1 and down 1 as well. So you essentially have these 3 points, kind of like on a Orion's belt or something like that. But they are, the graph between them then is going to be a little bit curved, not a straight line, not quite a straight line. So now it's just going to look like a cubic, and then curve a little bit, and then trace up, trace the asymptotes. Just like that. And this is one cycle of tangent. We're going to draw half a cycle on these other two now. So here was our next base point. I can go left 1 and down 1. We could go right 1 and up 1 again, but I didn't draw any tick marks over there, so I'm just going to draw this half here of the curve. And then I'll draw that other half coming from this side. So we'll go right 1 and up 1. Draw that point, and we will connect them. So something like that. If we wanted to draw more tangent, put some extra tick marks. And then from the base point, over 1, up 1. And then at this tick mark, it's 2 tick marks away from that starting point. Got to put an asymptote. Tangent, just like sine and cosine. I'm going to keep repeating that same pattern. And you can do as many as you like. Usually we like to see at least 2 periods. So this middle one is 1, and just because it's centered in the middle, those other 2 halves count as 1. Okay, so let's get into the transformations, and we'll start with some easy ones, and then the last one we'll do, we'll essentially just have everything thrown at it. So let's graph three sine of x plus pi over 2. So we're going to start almost all of these off the same way. Draw our axes. We're going to put our 4 tick marks on both sides. The vertical axis, then, we want to include as many tick marks as we need to for the amplitude. And we may want to account for any sort of vertical shift. So there's no vertical shift, which means we're going to be centered at the origin, or centered at the x-axis vertically. The midline will remain the x-axis. We will have to shift to the left a little bit. So let's go ahead and put 3 tick marks then for positive and negative y-axis. And now, well, before we graph it, we should figure out, at least get an idea of what the tick marks are. Vertical ones are easy, of course, 1, 2, and 3. But horizontally, it's going to depend on the period. So our period here, since that b term is just 1, period is still going to be 2 pi. Which is nice now, because our tick marks are then pi over 2, pi, and 3 pi over 2. Oh, excuse me. That reminds me. Let's go ahead and write down the general form. I don't know how well you guys went over this yesterday. I know you saw the formula, but I'm not sure how well it was explained. So let's just make sure we write down in our notes this general form. that if I have a function f of x is a sine of b times x minus c plus d. What do all these constants mean? So that a out front is our amplitude. It's our y stretch. B is the horizontal scaling factor. And in particular, why do we care about B, or how do we use this scaling factor here? Mainly in this equation, that the period is 2 pi over B. So that's a key one. You're going to want to remember that one. So when I first started off, when we're labeling our axes, the first thing we want to figure out is what is the period? And so since our B term was just 1, 2 pi over 1 gives us our period of 2 pi. So we can label the axes that way. C is going to be our phase shift. This is a horizontal shift. I'm going to say usually it's a multiple of the period divided by 4. It's not always, but most of the time if we're graphing these by hand, the reason we cut the period in the fourths is just because that is nice drawing cues of where we can find key points to plot and then connect the dots based on the shape in between them. So usually when we're going to shift it left or right, we want to shift it by one of these tick marks, which is a fourth of the period. Again, not always the case, and sometimes when it's not, doesn't line up with the tick marks we like to draw, it's going to be a little bit wonky. Maybe I'll say a few words on how to do that once we get to our final example, which is a little bit more involved. And then I guess the last thing is our D. So D is the midline, or also the average value. Right, our sine and cosine, it's the midline that they oscillate about. So that D is just going to shift it up or down. And so we can kind of just think of shifting that axis, the horizontal axis, up or down, from which sine or cosine will oscillate about. Similar for tangent, but of course the oscillations go all the way up to infinity and then out the other side. Okay, so let's get back to our drawing. We have our graph made, or our axes labeled, and nicely enough, our phase shift is pi over 2, which corresponds to one of the tick marks. So I'm going to use orange a lot. The orange is what I'm going to use for drawing ghost lines and ghost axes. These are just drawing cues. I'm not going to actually correspond to the actual graph. I'll use black for the actual graph. So since we shifted left, what we can do is just think about taking the vertical axis, and shift it left. And the horizontal axis is going to stay where it is since we don't have any vertical shifts. So sorry, that's not quite straight, but good enough. And then so once you have these ghost axes drawn, essentially start at the origin on the ghost axes and then go ahead and follow the same drawing process. Now sine starts at the origin, so I put that point there. Remember, if it's cosine, it's going to start at a peak. So we start at the origin, now the shifted origin. What are we going to do? We're going to go over one tick mark, then we go up to a peak. And just remember that the peak goes all the way up to 3 because of the amplitude. Back down to the midline, down to a valley, midline, peak. And then connect the dots. And then to the left, we go left one, down one, to a valley, back to the midline, up to a peak. And then connect the dots. So that's all there is to that one. Now, one thing you can notice is that, well, if we ignore this shift, what does this graph look like? It actually looks like a cosine function, right? Because cosine starts at a peak, then goes down. So that's going to be something that comes up if you're just given abstract information about a curve. You can actually use sine or cosine to model any sort of wave function. Doesn't matter. All it's going to change is this shift and maybe a flip vertically. And we'll try to get to an example of that at the end. Let's do one with cosine, though.
Can you show that equation real quickly one more time, the bottom one?
Yeah. The notes down here.
Perfect, thanks.
Yep. So let's do minus 1/2 cosine of 3x. So now when we draw this, got our 4 tick marks. The vertical scale only goes up to 1/2. So maybe I'll put 2 tick marks, positive and negative, on the vertical axis. And so every 2 is going to be 1. The horizontal tick marks, what are those going to be? It's going to be a little weird. So let's take a look. We actually don't have no phase shift, right? And then no midline shift. So that means the axes we drew, the original axes, are the original axes we're going to base the graph off of. And we can essentially just go ahead and graph it. Where does cosine start? It starts at a peak. However, we got to be careful. What's that minus sign going to do? It's going to flip everything vertically. So since cosine started at a peak, flipped upside down, it'll be now starting at a valley. And again, since we have no shifts, that is our starting point. Let's just go through the graphing process. That is a valley, so we're going to go up across the midline first, then up to a peak, midline, down to a valley. And let's go ahead and connect those. And then to the left, up to the midline, up to a peak, midline, and valley. So that's our cosine function. The vertical axis was easy enough to label. What about the horizontal axis? We want to make sure we include at least one label. Our period is going to be 2 pi divided by b, which is a weird number. 2 pi over 3 doesn't simplify, but that's going to be the 4th tick mark. How do we figure out what each individual tick mark is? We just divide it by 4. So 2 pi over 3 times 1/4 is going to give us pi over 6. So each tick mark pi over 6, 2 pi over 6 is pi over 3, 3 pi over 6 is pi over 2, and then 4 pi over 6 is 2 pi over 3. So again, often easiest to draw the graph first and then label at the end. And you'll notice a lot of these graphs are very similar, especially if they don't have any shifts vertically or horizontally. You essentially just draw a typical sine or cosine function, minding any sort of flips, and then label all the axes afterwards if you wanted. All right, let's do one tangent, and then we'll try to do one with one of the reciprocal functions, and we'll just throw everything in there. So we've got tangent of 1/2 x plus 1. Draw our graph. Tangent, I'm going to pick the tick marks a little bit closer since tangent is kind of narrow and skinny. And then how do we draw it? So we do have this +1 shift. What's that going to do? It's going to shift the midline up 1. So now we're essentially going to go through our drawing process relative to here. Tangent starts at the origin. And then every 2 tick marks, I'll have an asymptote. And then another point on the midline. So I'll go over to, draw an asymptote. Then go over to, draw a point at the midline. Then how do we find other points? So from the midline point, we go right 1, up 1. We go left 1, down 1. And those are other good points. So likewise from these other points on the midline, we go left 1, down 1. And this one you can go right 1, up 1. And then in between each of the asymptotes, connect the dots and draw something that looks like a cubic chasing the asymptotes. So that one will keep going if you wanted to draw it. And that's our tangent. What do we forget? Put some labels on the axes. So y-axis was easy. We have just 1. What about the horizontal axis? So the period, be careful with tangent. What was the original period? It's pi. So the way you would figure out your periods for tangent, it's going to be pi divided by whatever the b term is. So pi divided by 1/2. Be careful when doing these fraction divisions. I've seen a few mistakes come up quite a bit recently on the big quizzes. I'm doing some cross multiplying. Some of these law of sines had some cross multiplying errors. Just careful with all that stuff. Dividing by a fraction, remember, multiply by the reciprocal. So dividing by 1/2 is multiplying by 2. So our period is 2 pi. And we always write it so that every 4 tick marks is 2 pi, which means each tick mark is pi over 2. Questions on that? All right. So let's do one hard one, and then hopefully we'll have a little bit of time to do one of these more abstract problems. Let's graph -3 secant of pi over 2, x minus pi over 2, minus 2. So how do we graph this? The first thing we're going to do, Whenever you have a scaling factor, horizontal scaling factor, and a phase shift, make sure you factor that out. Because in this form, it's going to look like the phase shift is pi over 2. But really, the phase shift we're going to use is 1. And again, there's some algebra involved with factoring. Sometimes this number isn't the same as this. So factoring it, you could have to do a little bit of arithmetic there. So we want to factor that b term inside the trig function. And what we're going to do first is we're actually going to graph the reciprocal. And so what that's going to be, let's call it g of x. Same constants, except secant is 1 over cosine. Because we know how to graph cosine. Let's do that first, and I'll graph this one in blue. So I'm going to go ahead, draw 4 tick marks on either side. Our y scale might need a few tick marks. We need at least 3 on either side for the amplitude, and then we need maybe a couple more because we're shifting it downward. So our vertical tick marks, since the vertical scale is stretched by 3, we can make the vertical scale just 1. It's not a fraction or anything weird. The horizontal scale, 2 pi divided by pi over 2. What's that going to give us? Just 4. So period is 4. Nicely enough, we've got 4 tick marks. So each tick mark on the horizontal axis is just 1. Now let's plot our ghost axes. So based on our vertical and horizontal shift. Vertical shift we're going down to. So that's going to shift our midline down to. And then the starting point is going to go right 1. So we're going to consider this as like our new origin. And then we're graphing cosine. So cosine starts at a peak, but we've got a negative out front, so that's going to flip it upside down, which means from the starting line, we got to go down to a valley. So we will be starting down here at negative 5, 3 below the midline. And now all we want to do is I go over 1 tick mark, back to the midline, over 1 tick mark. We got to go up to a peak, so that's going to be up 1, 2, 3 from the midline, since our amplitude is 3. Then we go over 1 tick mark and back to the midline. And we can graph that side if you want. Scale is a little off there. Good enough. And now we're at a valley. So when I go over 1 tick mark up to the midline, over 1 tick mark up to the peak, If it helps as well with these vertical shifts, you can always graph, if you want to put in more guidelines for the top and bottom, for the maximums and minimums, you can do that as well, just to know where you're plotting it. For me, it's easy enough to count. So we go over one, back to the midline, over one, back to the minimum, especially once you've drawn one or two minimums, you can just line them up. And then over one, back to the midline. And then we want to connect all of those guys. So that was our cosine. Make a little legend there. So the blue is the cosine. We want to graph our function in black. And our function, original function, was secant. So how do we graph secant? It's not too hard. Once you've graphed cosine, which we've got, anywhere where it touches the midline, draw an asymptote. So it'll be an asymptote at the y-axis, asymptote here, and an asymptote here. And now in between the asymptotes, you're either going to have a peak or a valley. Just invert those. So wherever this peak is, put a dot. And then since it's a downward hump, we're just going to invert it and put a U. So it's going to touch right at the max. And then it's going to go up and trace the asymptotes. On the valleys, it's just going to be an upside down U. Got a peak. It's going to touch at that peak. Draw a U. Touch at the valley. Upside down U. And that's it. That is our secant. So cosecant, you're going to do similarly. You would draw your sine function first, and then the same process. Wherever it crosses the midline, vertical asymptote. At the peaks, draw your U's. At the valleys, draw your upside down U's. Cotangent is one of the weird ones. Cotangent, we don't have time to do one, but cotangent is essentially like tangent, except they're flipped and then shifted by half. So the asymptotes, and wherever you want to just change wherever the midline, wherever it crosses the midline versus an asymptote. So this would be an asymptote, that would be a point. This would be an asymptote, next one would be a point, even though it's an asymptote for tangent. So you flip all those and then just flip the direction for cotangent. Let's do one problem that's a little more abstract with all this stuff. Ooh, I'm just out of paper. Let me grab some. Here, I can use this one. So let's say we want to find a function and let's say a sinusoidal function with successive peak or max and min at 2, 7 and 10 minus 2. So this one, I'm not going to draw the full graph just because the scale is a little weird, but we essentially just have a sine curve or a cosine curve. Whenever it says sinusoidal, just means sine or cosine. And we have a peak here at 2.7 and a valley at 10 minus 2. And what we want to do is come up with a function to model it. In other words, we need to figure out the A, B, C, and D. And we can replace sine with cosine. Actually, in this case, cosine would be, it'd be a little bit easier, mainly because what do we like about cosine? Cosine starts at a peak, right? Our initial point we plot for cosine is a peak. So anytime I'm given the peak, we can just take that as the starting point. But let's do sine since it is a little bit harder. It'll give a few more things to talk about, and then we'll mention how to do cosine at the end. So we want to find all of these constants based off of the information given. One thing hopefully you notice in graphing these sine and cosine, in between a peak and a valley, it always has to cross the midline, and it's always halfway. So our midline is always going to be halfway in between the peak and valley. It's going to be halfway horizontally and halfway vertically. In other words, that next midline cross is going to be the midpoint between a peak and a valley. So our midpoint, remember how to find midpoints. We take the average x value and the average y value. So we'll get 6 and 5 halves. 5 halves for that point. Why does that help us? Well, the midline is our D. So we instantly know that. What about the 6? So if we're using a sine function to model a curve, where does sine start? It starts at a midline point. However, sine should start at a midpoint and go up. What's going on with this one? It's going downward. So we can still take this as our starting point. What do we have to do? We just have to flip the sign upside down. So we can take our 6 to be our C value, our phase shift, and then just make A negative. So we're essentially putting these ghost axes in right there. So we're going to take our C and D as those values, those X and Y values. And then we need to make the A value negative, so we'll start off decreasing. How do we find the A value? A value is the amplitude, so it's the distance between the midpoint and the peak. So midpoint to peak. Or you could do half the distance between Y, or between the peak and the valley on the Y direction. So if we just do 7 minus 5 halves, it's 14 halves minus 5 is 9 halves. So that's the distance, and we just want to make A negative, so let's make A negative 9 halves. And then the last thing we need to figure out is B. So how do we figure out B? B is related to the period. So if we know the period, we can figure out B. And just remember that a period is from peak to peak, or valley to valley. We don't have another peak. So when I just go from peak to valley, how far is that? Half the period. So half the period, how far do we go horizontally from peak to valley, or valley to peak? We go distance of 8 units. In other words, the period is 16. So if the period is 16, the period should also be 2 pi over b. Multiply the b over, divide by 16, and we get that b should be pi over 8. So all in all, our function should be minus 9/2 sine of pi over 8 x minus 6 plus 5/2. If we wanted to do this with a cosine, so the thing about cosine is, well, where are we starting now? Cosine starts at a peak, so I could have adjusted the ghost axis to go right through at that peak, which means it would have been a 2 as a horizontal shift. The period is still the same, which means the b term is going to be the same. The midline is still the same. And the amplitude is still the same. We just got to decide, do I need that positive or negative? And since we're modeling this cosine function to start at x equals 2, since that is a peak, that's how cosine naturally starts, so we don't need to flip it. We'll keep that positive. So either of those functions would have worked. Any questions?